So my name is Tim Young. I'm from the CIC, which is the Curtin Institute of Computation. And I will be talking a little bit about Python and a little bit about R. Rob Syme, who also, he's not within the CIC, but is another researcher that worked with us on a lot of things. He should also be coming, hopefully at about 11 o'clock, to talk a little bit more about R, and you'll understand why very shortly. But we're going to start with Python. So a really good question is, why Python? Why should you use Python for your research? And there's a lot of really great answers to this. First of all, Python is a very, very well-established language. It's been around for well over a decade now. It's gone through multiple iterations. We're up to Python 3, but Python 2 is running concurrently. The two sort of work side by side depending on what packages you want to be able to use. But its age isn't just the one great thing about it. Python is also eminently readable. So if you compare two pieces of code, one in Python, one in Java, one of them is much, much more obvious as to what it does than the other one, and it's the Python one. So print hello world does literally what it says on the tin. It prints the word hello world. To get that same effect in a language like Java, for example, you have to start defining your classes, start talking about what you're going to put your words into, create the container, and it's a mess, it's a nightmare, no one wants to deal with that. So Python is readable. In fact, Python is so readable that you can write poetry with it. So this is a nice little poem that someone wrote back in 2011, so again, showing how long the language has been around for. Unfortunately, this piece of code doesn't do anything, it's just readable, but it's a really great example of why Python is so easy to use, because almost all of those words, even if you don't understand a programming language, if you've never done programming before, a lot of those words mean things to you. They are English words that are easily readable. Things like def, short for define, it's fairly simple. Try does exactly what it says in the box. Yield, except, for, with, all these words are things that we're used to, and in fact, it's a logical language, so it's something that you can take your data, apply a series of logical tests to, and come out with something that is hopefully useful, and hopefully a little less somber and dark than that poem. Python is something I've worked with for a very, very long time. This very messy plot here was created very, very simply with Python using a radio telescope built with spare parts from Dick Smith. So this was actually part of my honours thesis a million years ago, and it's looking at the rotation curve of the Milky Way. So with off-the-shelf components and a little bit of Python, you can actually measure how fast the galaxy is rotating, which is also incredible evidence for dark matter. So from something really, really simple and a really simple piece of code from memory, this code in Python took maybe 3 months to write, and it takes about 24 hours to run, but only because you have to run the telescope for 24 hours to get the data. And this is the plot you get. So you can actually use this to prove that there is dark matter in the universe. I won't go into that too much because it's a lot more fun, but it's not really relevant at the moment. But the point is that you can get some data out of it really, really simply. And as a young honours student, I was able to do that with very, very little background in programming at all. Python is also incredibly scalable. Python allows you to do pretty much whatever you want with it. Don't think of it as one particular language for writing code in. It's almost like it's a type of language. It's a container with lots of different languages built into it. Because Python has been around for so long, it's been used for so many things, people write so many packages for it, it can be used in almost any context that you want it. This is an example written by my director Andrew Roll and a friend of his as an example, using Google Maps data, or actually I think it was Open Maps data, to plot the outline of the United Kingdom using just the latitude and longitude of every pub that exists in the United Kingdom. And so this, with a small bit at the top as well, just importing the packages, is pretty much the entirety of the code that you need to do that. So they've taken all the data that's in OpenStreetMaps, narrowed it down to the bits that they want, which is just the location of pubs, and use that to plot it out to something that actually recreates the outline, and in fact most of the inside as well, of the United Kingdom, with no information about where the United Kingdom is or isn't. So that data isn't in there. It's just the latitude and longitude of pubs. And that again was just a bit of fun that they decided to do as an example of how to use the code. So it wasn't something that was premeditated, it was just something through trial and error, very, very simply, taking a bunch of data from the internet that's freely available and using it to get something that's fun. Another example from Ramiro, who was the other chap, which I really like as well, is looking at submission data from Reddit. So, do we go to Reddit? Yeah. Any of us Redditors? Maybe, maybe not. Reddit is fantastic. It's actually a great place for like a test bed for psychology. Do we have any psychology researchers? No? Again? It's fantastic to look at different dynamics and interactions between people. This was a really interesting project, and it goes on for a lot further to dig deeper and down into the data, but it's essentially looking at how quickly a post on Reddit reaches high levels of popularity and figuring out when that post was posted to figure out essentially what is the best time to post to Reddit if you want your post to go viral. So again, using nothing except the data that was freely available on the internet, using Python to pull that data down in a very, very simple method we call scraping, you can get all this data and start to plot it out in very interesting ways. You can then start to subdivide it out and look into things like which specific Reddits or subreddits post, let's say, very strongly on a Sunday afternoon, etc., etc. So there's lots and lots of ways in which you can take very simple data like that, use Python to plot it out into something that's much, much more interesting. But Python is scalable up to, for example, tracking the emotion on people's faces. This is a machine learning project that's also very, very simple to use, and in fact, most of the work has been done for you. You don't have to learn the basics of machine learning and all the way through to code this thing up yourself. You can download packages that are freely available on the internet that can take a simple webcam or a piece of video that you might have pre-recorded, and it can start to look at what are the emotions on people's faces. This is a really burgeoning area of research at the moment. There's a lot of buzz and activity surrounding it, and it's really interesting to see some of the results that are coming out of it. But it's not just if you want to find what people's emotions are. There are so many different things you can use these very simple algorithms for. So you might not be interested in emotions on people's faces, but you might be interested in object recognition. You might be interested in how many times a certain object appears in a magazine, for example. You might be interested in whether or not a vein is bleeding in a CT scan. All these kinds of things are really, really interesting examples that use these kinds of algorithms for. And right the way to the other end of scalability, someone for a bit of fun also programmed the entirety of Minecraft in just 900 lines of Python code. And that's insane. The ability to render procedurally generated worlds, which some people might spend a lot of time, maybe hundreds of hours in. To be able to do that in a language like Python is really, really interesting, because we've taken something that could be so simple as plotting the pubs in Ireland through to generating entire universes that go on literally forever, or as far as a 32-bit float will let you go. Python is also a community, and that's, I think, the strongest part of Python. Python has been around for so long. This is a website called Stack Overflow. If you are doing anything in research at all and you're using a computer, you should be aware of Stack Overflow. If you haven't been aware of it up until now, please, please, please check it out. It is where almost all of your questions are going to be answered. If you have any question about how do I do this really obscure specific thing, 9 times out of 10 the answer is on Stack Overflow. The Python community on Stack Overflow has already answered 797,000 questions, and that number goes up every single day. It's one of the most active communities on Stack Overflow. In fact, I think it's top 5 at the moment. And it's really, really friendly community as well. So if you do have a question, you think it's really obscure and it's using some arcane data set that no one's ever heard of, chances are people on there will go, hey, I've never seen this before, but let's give a crack at trying to solve it together. And then multiple people might jump on and say, that's a really good solution. Here's a slightly better one that uses fewer lines of code. You shouldn't use that statement, etc., etc. So it's a really open and welcoming community, and that's one of the things that is really, really helpful when you are doing your research. Rather than beating your head against a wall and just working on the problem by yourself over and over and over again, to jump online and find these answers is really, really nice. But I think one of the greatest parts of Python, and the part that I'm most interested in, is the fact that Python is free. There are no paywalls, there are no subscriptions, and it means that I can eat vegetables this week, which is fantastic. So Python is a completely open language. Open in terms of the fact that it costs no money, but also open in the fact that you can change and edit it to do things that you might want to do. So you're not limited, you can see everything that's going on in the background. That's one of the great things about being able to debug your software in Python. So I don't want to talk poorly about other languages that you might have heard about, but a lot of those things, when you get some of the errors that might pop up, they're quite arcane. You can't really figure out what's going on. They don't necessarily tell you the full, what we call the dump of the error, so to see exactly what's gone wrong, where the exception has occurred. Python is completely open, and so it does tell you all of that. You can put the entire dump onto the internet and say, "Internet, please help me," and someone more than likely will. So Python's really great in that respect. I'm going to rush through the next section as well, because I think the question and answers part is where most people are going to get their help from.